Hello and welcome to a new episode of On Air with Daikin. I'm Matteo Dall'Ombra, your host, and today I'm joined by a very special guest. I have with me today Dr. Anastasia Mylona, CIBSE Technical Director. Welcome. Thanks for joining us.
Thank you very much.
It's been really a pleasure to have you today. I feel like we might spend the full day talking about all sort of very interesting
Indeed.
things because I've seen a lot of the stuff that you've been doing recently. And but I guess before we go into too much of the depths of the conversation, if you want to give us a bit of introduction about yourself,
Yeah.
what you do for CIBSE, what led you to what you are currently
Yeah, I can spend a
doing.
whole day talking about that as well. But I studied architecture. My first degree is in architecture, and then when I finished, I was very interested in the environmental impact of buildings, and that wasn't covered in the kind of classic architecture
Yeah.
course that I did. So I started looking at postgraduate courses, and that led me to the UK. I did my PhD at the Wells School of Architecture in Cardiff, and then my postdoc at the University of Oxford. Those 2 years, I looked at the impact of climate change on buildings, which immediately kind of drew my attention and my interest. And I brought all that knowledge to CIBSE when I started working for CIBSE back in 2008. I created all the body of knowledge that talks about climate adaptation, overheating, future weather files. I know we're going to talk about all that further
absolutely.
down. But what engineers need to know and what are the tools and the resources they need in order to adapt buildings to the future potential climate, higher temperatures, higher or lower rainfall, wind, and all that.
I feel massively underqualified to have this kind of conversation with you, so I'll try not to embarrass myself with.
I'm sure you'll be fine. I'm sure you'll be
with my
fine.
fiance.
But
But no,
yeah,
it's
then
great to.
so then after I did all that, I was asked to lead the kind of the research portfolio within CIBSE. So I did that for a few years, and then the next step is the technical director. That I have my own team within CIBSE, the technical team that we lead on kind of the priorities for the industry, how we can support our members within the UK and internationally. Where do we need to draw our attention? What are the future challenges? How can we meet those challenges?
Yeah.
Guidance, training, events, the body of knowledge to support the industry.
And I guess speaking about how do we meet the future challenge, probably a good place to start, as if anything, I would say. I saw that you recently spoke at earlier, some months ago, at the CIBSE Technical Symposium, which was fit for 2050, which I guess is a big, it's a big deadline, as a big.
There is something
horizon.
about 2050, right? There is something about 2050. We have the net zero target that the government have kind of introduced. We also have that. I don't know if you're familiar with the IPCC scenarios about climate change, and you see up to the 2050, you get kind of similar kind of trends of the different scenarios, and then there is that kind of change in basically what we do now is going to affect the climate post 2050. So it feels like a deadline,
no pressure,
right? No pressure. It feels like a deadline. The 2050 is kind of when we need to have achieved everything that we need to achieve, so that then our climate, our lives, our society, it's sustainable.
Of course. And speaking of sustainable, how do you define, I guess, how do we drive for sustainability, or how do we need to change maybe the design of buildings to be more sustainable? Because I think, I definitely feel it's a big thing. Of course, everybody within our industry talks about it. But I also get the impression that everybody talks about sustainability in a slightly different way. So I don't know if there is a more common trend that we can observe, or there's a more like a principled way of thinking about sustainability in buildings more than others.
I would go even further than buildings. I think sustainability is a state of mind that goes across everything that we do. not just the buildings. I mean, as engineers, we are focusing on buildings because that's what we can kind of implement. But I feel that sustainability is something that we need to educate the wider audience. You know, what are the principles of sustainability? You reuse, you recycle, you use less.
Yes.
Basically. So, and then that means that when, as engineers, we are trying to implement sustainability principles in buildings, then you have the audience ready, and they understand what you're talking about and why they need to invest in these kind of extra measures. What they consider to be extra for me would be kind of basic, right? So sustainability, I think, is something that cuts across everything. I mean, government, priorities, the way they invest, what they invest on, and all trickles down to then enable engineers to design better, and more sustainable.
No, of course. No, totally agree with you. And but I guess if there is a way that we can maybe try and narrow it down to more maybe around the building industry, because a lot of the people that listen to this podcast, they are within the building industry. So try to give them a bit more of a guidance, I guess, on things they might be having to, like trends to look for, or maybe some of the major changes that we think they will need to go through between, let's say, now and that horizon in the future. Is there anything specific that comes out?
Yeah, the trends. Okay, yes, I can talk about that. So until recently, I would say about 5 years ago, we were talking about energy efficiency as part of the sustainability. We talked a lot about efficiency in systems. We talked a lot about reducing the amount of energy we use, occupant behavior, but all it was about energy efficiency, reducing energy we use. But now I think the new focus needs to be on embodied carbon, because if you look at the whole life carbon of a building, operation is a big part of it, but it's only a bit of it. You have already invested a lot on carbon emissions from kind of conception, trying to kind of construction stage, the material, the processes, where everything comes from, what do you install, how often do you maintain it, you replace it. So all that is actual carbon and carbon emissions that as engineers we can reduce, and we can have kind of solutions. And there are different ways of dealing with that, choosing, well, to start with, retrofitting more. We tend to like to demolish things and start from scratch. I think that it's fundamental that there is a question, can we reuse the structure? Because there is a lot of embodied carbon within a structure. To just demolish it, what are you going to do with the material? It's just going to the skip, it's a waste of material that it's valuable. So I would say the embodied carbon is kind of the next big challenge for the industry to tackle.
I'll probably go as far as saying that it's not even the next, it's kind of, it already is.
You're
here,
right.
in a sense.
You're very
Because we've
right.
seen, even just as a manufacturer, we've seen a massive and very sudden shift in mentality in terms of the conversation that we're having, like exactly what you just described. So we went through a lot of years where it was more about the operational efficiencies, and it was all about how can we maximize SCR, SCOP, how can we minimize the energy usage and things like that, to almost overnight, but maybe not really almost overnight, but very quickly, okay, what about the embodied carbon? And to a certain degree, we are already jumping almost to the next step. So we started looking at things like TM65 within the UK. And by the time we released the first TM65 documents, then we started to get questions about, well, what about EPDs?
Yes. Yes.
And so, what about what? And again, so it took us a bit of a of a time, but definitely compared to, I would say, the past, and I would say how long we've been talking about energy efficiencies, this shift toward carbon seems to be happening much faster at a much faster rate compared to the past.
Can I ask you a question?
Yeah, of course.
Where do you see the who is asking for embodied carbon, or who is driving the agenda for the manufacturers?
I would say two main sources. It's either specifiers, or investors.
Interesting.
So it comes still through specifiers, but because they may have receive requests from investor, or let's say from their own end users, so who actually sort of will be occupying the building. Yeah.
Okay, that's very interesting, actually.
Yeah. It's probably a 50-50 at this stage in terms of where the original request actually comes from. But I think we still see probably being a bit of a niche sort of type of request overall. There's still, I think we still see probably a significant focus around the energy efficiencies in the operational stage. But certainly we see sort of the increase of the demands for the switch to carbons and embodied carbons, and in some cases toward EPDs. Like, they are progressively smaller chunks, but I feel like they're getting sort of stronger and bigger over time. Which was very interesting because it also meant that we as manufacturer, we had to go on a journey, our own journey essentially, to get the data, because initially, to be perfectly frank, we were not ready. We just didn't have the data because it wasn't a request that we were getting.
Yeah. And when we started thinking about TM65 as a methodology, how do you go about measuring systems embodied carbon? And I remember we spent hours and hours around the table. It can't be done. It can't be done. It can't possibly be done. Because, of course, in our head, we had EPDs as the golden standard. But then we said, okay, how do we approach that step by step? And that's where kind of the whole idea about having a kind of very basic and then a bit more advanced, and then the kind of the TM65 approach, where, okay, what is the biggest factor in terms of embodied carbon? It's the material, where they come from, maintenance and replacement. Let's figure that out basically, and have coefficients to kind of calculate the rest.
Yeah. But I think it was really the other big advantages of TM65, at least in the way that I see it from a manufacturer perspective. It also allows you sort of a very clear path from sharing of knowledge point of view, and from how do we educate the rest of the market, because I think it would have been probably too strong of a jump to say we go from zero to, let's say, mandate full EPD overnight, especially with in some areas, you can call it maybe a lack of awareness of why are we looking at carbon, why is it important to look at carbon, right? And so I think that certainly one of the advantages of that TM65 approach is, okay, you go from zero to gradually a first step where you might be able to do a bit more generic calculations and get sort of your feet into the water slowly.
Start understanding your product as well as a manufacturer, and as a designer, understanding what are the implications of the systems that you are designing and you are putting into a building. So you're absolutely right. It is a kind of culture change and a step approach into understanding the impact of systems in a building.
Yeah, and even not just that, but even again from a point of view of us as a manufacturer, it kind of gave us ideas on how to change and evolve the products, because suddenly you're kind of asked to do a bit of a X-ray almost of how you put together your products, all the different components, where they come from, the impact of choosing this bit versus that bit. And then it kind of gives you the idea of saying, well, if we, I don't know, change maybe this material, we change this process, or things like what we are trying to do already more and more, which is using recycled material in the productions, using recycled refrigerants. How does that all change the balance? How did that shift the overall sort of carbon footprint of a product? So it kind of gave us a lot of idea to begin with in how we can change and sort of almost start that domino effect, right? Because if we are able to, and not just us, but in general, if all the products that are used in a building, so if we're able to change them from a manufacturing stage and progressively make them a bit less carbon intensive than the ones they're used, they will contribute less overall, and so on and so forth.
So have you question?
Yes. I like that.
Have you changed any product based on the embodied carbon calculations that you have done? Just out of curiosity.
Yeah. So I would say probably not yet fully, but certainly now that we are starting for certain products line, we are looking at kind of next generations, especially tied together with new refrigerants and where we need to go from an F-gas point of view. I feel like a lot of the things that we are learning, they will be part of the conversation when sort of the R&D center looks at, okay, let's do these or let's do that. And again, something that I mentioned that, for example, from a refrigerant point of view, which is normally the largest single contributor when it comes to making a calculation in embodied carbons, we started using recycled and reclaimed refrigerants in a lot of our products almost a decade ago by now. Okay. Progressively in small chunks now to cover sort of full product ranges. And even from a point of view of the actual sort of physical component of material, we're looking at trying to find ways to more reliably use recycled components or recycled materials or recycled metals, for example, to again lower the impact. And I think one of the things that kind of differentiate us versus other manufacturers, because of the fact that we have European manufacturing, European R&D, we are very close to what goes on around the market. So we're really close to all the dynamics that we see happening around Europe, and we are a bit more, we can adapt a bit more easily compared to maybe other manufacturers that have less of a sort of local presence. But yes, it was just fascinating also when we turn around to our factories and our colleagues and say, this is what we are being asked for, and sort of seeing also how their changes and their adaptations and making sure that they found new processes to gather the data. Because at the end of the day, we've always been at Daikin. One of the things that we've always liked to sort of put forward is the fact that we always want to be able to 1,000% stand by the number that we publish. Yeah. So it took us a bit to get to the point where we had certificates and calculation for multiple products. And EPD, again, is kind of a in progress thing. Like we don't have them for every single product. But one of the reasons for the time that it takes is because we want to make sure that when it goes out, we 1,000% stand by the number. We've done the proper research, and we know that we can reliably sell to our partners. Feel confident in using this number because we've done the research.
I guess that's why at CIBSE we have started the certification service as well.
Yes.
I don't know if you know. Yeah.
Yes,
the TM65, the embodied carbon. Basically, it's for manufacturers to be able to say this is the number and actually has been certified by a third party, and then there is kind of like for like comparison. We all follow the same methodology. We all have been certified. Which
I think that's actually a big thing. Like the idea of saying, you can have a bit of more of a plain level in terms of comparison, because I guess at some point, I don't know how you see it, but from our point of view, I don't think we're still, or yet, shall we say, at the stage where, I don't know, choices are made based on carbon. But I think we probably are not too far from that step.
I think so. It feels like it's moving quite fast. But I agree with you. I think we are still in the process of understanding the products, understanding the impacts, understanding what needs to change. But yes, I don't think any big changes have been implemented across the industry yet. But like we are trying to get the government, well, few of the kind of professional bodies, we're trying to get the government to legislate. Have you heard of Part Z?
Yes.
So it's a piece of work that we did to say, okay, if you are serious about the net zero targets, then you need to think about embodied carbon, and this is potentially how you can go about kind of regulating it.
Maybe what you mentioned, Part Z, maybe if you can expand a bit more, so if people are not familiar with what it is, we can give a bit of a background.
So building regs, they are a set of parts that they are looking at different performance or aspects of a building. So you have part L on energy efficiency and conservation. You have part O, recently introduced for overheating. You have part F, which is all about ventilation.
Yep.
So you have all these parts, security and fire safety and all that. So part Z is a theoretical new kind of part of the building regs that introduces the idea of measuring and regulating for embodied carbon. And it's not just the systems; it's everything. It's the whole building, which I think it's a very important next step if we are serious about net zero.
Yes. No, you're right. I mean, there's always, I don't know, sometimes people don't like government to get involved with stuff, but also at the same time, you really want to have that backing, and you really want to have some very clear line which is drawn and said, this is it, this is the direction.
Unfortunately, you need that kind of stick.
Yes.
Because the carrots can only take you so far, and then you just need the stick basically.
No, that's absolutely, that's very fair. And similar to that principle, something else that we've seen quite a lot of already used is it always takes me a while, but it's the UK net zero carbon building standard, which is
yes. I mean that was all industry, right?
Yes.
People got together, institutions,
which I think that's what makes it really nice, really fresh, like
exactly.
And maybe that carrot that you were kind of mentioning, like
exactly, because it's actually the industry comes together. It doesn't happen very often.
Yes.
But this time, this was a kind of a massive undertaking. We are talking about hundreds of people being involved, potentially thousands as well. If you think about all the data gathering, it's all based on evidence, on energy and embodied carbon of buildings, real buildings. So many hours of analysis, so many hours of debating how we're going to account for all the different aspects, for the different types of buildings. I think we have 14 different types of buildings in there. And it creates that roadmap of what do we need to do between now and 2050 in order to achieve those net zero targets. And it includes both new, so a roadmap for new, which is relatively more straightforward. You have more flexibility to implement different options on a blank page.
Yeah, of course.
But also it provides a roadmap for refurbishment of all these different types of buildings. So, what are the key decisions that you have to make between now and then in order to refurbish and adapt a building for net
And
zero.
as you mentioned toward the beginning, that's the area that we should definitely focus, like how can we reuse what we have rather than just tear it down.
Exactly, yeah.
And again, but the other fascinating bit of the standard is how quickly it came to be, in a sense, and especially from a sort of publishing the first initial framework to actually seeing it already implemented. We already came across some project where it was clearly specified that was what the building was being designed toward, and it goes back to what we were saying in terms of how fast the shift is happening. It seems very different compared to the past.
I mean, we had some really powerful people involved, some really big brains in there, and leadership, really amazing people that sat around and said, okay, we need to do something about that. I mean, it still took a couple of years to put together, but yes, you're right. For such a big undertaking, it actually happened fairly quickly. And there was a lot of interest on the pilot scheme. So we had more than 200 projects enrolled and run the pilot for the kind of the first iteration of the standard. And we are now doing the analysis of all the data that we gathered from all these different projects. And we are working on version 1, which is the proper one. Checking what we said is realistic, fine-tuning based on actual kind of projects that they use the standard. So we're hoping to release that end of this year or beginning of next year. So relatively soon. We'll see.
So again, speed
Yeah,
of
yeah,
iteration.
yeah. Of course.
Because I guess also not to lose the momentum. Like once you start, you just want to keep going.
Exactly. And we are talking to government as well. MSCLG and DESNES, because they are interested. Of course, this came from industry, so they are.
I guess it gives it maybe even a bit more of a, not that you need it, but almost like extra validation to the fact that the people that work within the industry, that's what they want, and they clearly are telling everyone what they want to push the industry forward, is to continue to make it successful.
Yeah. If it comes from the industry, then nobody can complain, right?
Fair enough.
You said you wanted that, great.
That's very true. Yeah. And I guess the other thing that it's really important about that, or let's say that came out really good from that standard, is it really, again, I guess, shift some of the mentality to the continuous monitoring of the building.
Yes.
So rather than say, well, it's all been designed up to whatever standard.
Golden standard, yeah.
It's up, people are in, see you later.
Yeah.
To instead of, it's a continuous thing. Now it's up. Now the job start actually almost to a certain degree. Like, absolutely. Yes, we've done the design, but that's almost this one of the smallest part, because again, going to what we're saying and making sure that we can use it as much as possible. That building might be up for, well, hopefully for a very, very long time. And so that impact of the life is going to be even greater than actual the construction stage.
Yeah. And there is always a fine tuning, right?
Of course.
You installed, it's brand new, people don't know how to use it. There needs to be that kind of constant interaction to make sure that the building performs as supposed to.
Which is, it's a massive thing, because we also see it again from the product that we normally deal with. There is a significant component, or let's say a significant amount of fine-tuning that you could potentially continue to do, because again, building, they don't stay set in stone for very long. They start maybe with a certain type of occupancy, with a certain type of segmentation within the building. And then a few years later, I don't know, new tenants move in, renovations, things change. But I get the feeling that it's not given the fact that people would always come back and say, okay, let's see how this air conditioning, this heat pump was set up. Is it still an appropriate setup for what the building wants now? And that can make a significant difference from an energy point of view, which means from a carbon point of view. So having something that forces you to constantly reevaluate and assess where you are versus the target, how can we improve, it can only be a positive thing.
Are you getting involved as manufacturer in the...
Well, we were a small sponsor of the standard originally. But again, from our point of view, we are trying, we've always tried, but I think we'll try even more into the future to be more involved and be there where this type of conversation happens, because we know that we can be a non-insignificant contribution of the overall emission of a building. So we want to be there. We want to make sure to do whatever we can to do our part and our contribution. And again, from a point of view of making sure that we stand out as a trusted and reliable partner, especially when it comes to the request for data, because that is, I think, where we can make a significant difference by being able to supply that information. Because more and more, we see that increased demand for data, because models are getting more complicated, because there are more things that need to be checked and balanced. And again, not just from the design stage, but we are also trying to position ourselves in a way that we can be in a position to continuously supply that information on an ongoing basis. So once things are up and running. And so we're investing in things like cloud infrastructure and cloud control, so that we can give that easier access. Because again, it's not just about the number itself, it's also how easy it is for us to provide that information, to make sure that, again, it can be used in a reliable way, in a continuous way. So yeah, it's an evolution. Again, for us, it's an evolution because it's a completely, like going back to what we were saying, it's a very different shift in mentality compared to what we were using in the past, where we were asked for a certain amount of information and that's it. Now we are challenged more on a continuous basis on a different type of information, and then also the frequency at which we can provide that information. but all the better. As that we
we like data.
I like it too.
I like
so.
it.
When I started this company, I was doing what other people didn't want to do, which involve a lot of crunching numbers on Excel spreadsheet and try to make sense of all of those numbers. So yeah, that's why I don't really have any problem in challenging and going back to our factory and saying we need more data. We need to be transparent, because it's not just because we want. It's because the market is directly asking us for that information, and it's the only way to support that transformation.
That is great news, actually, that you get asked for data, not just from CIBSE, but like from clients and other
absolutely
people. So that's great news.
And more, and as I said, more and more, and so we always try to find a way to make it easier for us to share that information.
That's good.
Speaking of data, there is another type of data which was recently released by CIBSE, so the new weather data.
Oh yes.
What can you tell us about?
So that's my baby product.
Okay.
Product project. So that's one of the things that I implemented when I joined CIBSE, is the what we call the future weather files. The idea is that what you design now, the models that you build and the weather profiles that you use to assess the performance of a building, it needs to be representative of future climate, not just now, because the building is going to live, like you said, 80, 100 years, depending on what kind of you're designing. So we started using the UK climate projections that they are released by the Met Office every few years, and morph them into observations to create a set of profiles that they're more representative of the current climate, but also future climates. So we just had the release of the latest of this kind of set of weather profiles for the industry. I would say the biggest shift, not just the fact that we used more up-to-date information and, like you said, data. There is so much more data compared to what we had 20 years ago, 15 years ago. There is now satellite data. There is data, like everybody kind of creates data sets, measures things. So there is huge availability of data. That's great, because it means that you can have more locations, you can have more data sets that you can combine. If one is missing a variable, you can kind of add it from another data set. But I think the biggest shift is that for the first time, we are recommending for what we call a current climate to actually use a 2030s baseline.
Okay.
So it's not, so traditionally we used 30 years in the past, so it's already out of date, right? It would have been 2023, so anything you design is already in the past, kind of thing. So now we are suggesting that you use something that takes you up to 2040 as a current climate.
How was the shift perceived, I guess? Or?
So far, so good. Nobody has said anything. And actually, going back to the previous conversation we had, the pressure did come from the industry and said, when we're talking about climate change, why are we still considering current the past climate? We need to be looking at future. So we listen to that. I mean, I was always in favor of that. But as the industry upskills and gets more kind of up to speed and comfortable with the new challenges, I think I haven't had any pushback on why are we using future. It's not really future, it's just a set of profiles that they are representative of now and the near future. So I would say that's the exciting bit. And we're trying to talk now to, these profiles are used in compliance, Part L and Part O, as we mentioned earlier. So energy, conservation and overheating. So we're trying to talk to the government to see if they're going to adopt the new sets of weather files.
Just for the, I don't know, for the other 5 or 6 data nerd that might be out there, how do you get to creating these new profiles? No, talk me through.
I'm not the right person to respond to that. I mean, I know the high level kind of processes. There is a method called morphing. So what you do is you take the database of 30 years. You choose the year.
Yep.
So depending on if it's for energy, it's a compilation of average months.
Okay.
And that creates the test reference year. Or you choose based on how extreme and what is the type of extreme you're looking in terms of heat, summertime, weather. We have 3 different profiles. One is kind of relatively hot. One is high spikes of really high temperatures but short period. And the other one is low temperatures but longer period. So you have different profiles for different applications, if that makes sense, and different risk assessments. And you choose those kind of hourly profiles over a year, and then you use that morphing method to add the projections that come from the Met Office on these profiles. So the different variables will follow a slightly different process. But ultimately, we use probabilistic projections that says you have a probability between 10 and 90. Your mid probability is 50th. And the changes in temperature, for example, is going to be from 2 degrees to 8 degrees, whatever. This is just random numbers.
Yeah, of course.
And that's why the data sets that we release, they're also probabilistic, because then you can do, depending on the type of building you are designing, you should be able to assess your risk. So if your occupant's high risk, it's a care home or school, young kids, or, then you should be looking at kind of higher probabilities, higher changes in temperature when you're looking at overheating. When it's an office where you have your air conditioning and your systems, then perhaps you go for the medium 50th probability. Yeah. So I think it's very important for the industry, when they're thinking about climate change, to start thinking about incorporating a risk-based assessment rather than a single file to assess the performance of the building.
Fair enough. So we'll put all the links in the descriptions, but where people can get these new updated models?
Everything is on our website, on the CIBSE website. You can find all the resources we have there. They are over there. Like you said, we can send you the kind of direct links. But it's our kind of headliner for this year, so it should be really easy to find.
Fair enough. I'm sure it will be. So how long was that process of going from the previous models to these new models?
It took us 3 years.
Oh wow.
Yeah, 3 years. A lot of resources, a lot of statistical analysis. We had a KTP. I don't know if you know KTP. It's the Knowledge Transfer Partnership Associate.
Right.
Those schemes are they're great. I would recommend for Daikin as well. Basically, you get government funding to get a researcher into your business.
Yes.
To develop a product, and then the company commercializes the product, and that can be an actual physical product, it can be a guidance document or a tool, it can be a process. It's a great resource for the industry and academia to work together. So we had a KTP associate for 2.5 years, and then the dissemination took us another half a year, kind of to put it all together. Half a year or a year? Probably a year. So that takes us to 3.5 years to actually create the dissemination tool, the packages, the kind of marketing and all that. The testing took a long time.
Fair enough. And I guess when you have such a long horizon, you really want to make sure that you consider as many different possibilities and probabilities that you can think of.
Absolutely, yeah. And we had great involvement from industry, from software packages as well. Everybody volunteered time to test, to work together. Really kind of amazing project. it is one of my favorite projects, I have to say.
It's good to see you that, again, the industry kind of rallies together for a common objective.
Absolutely,
I think we just need more of that.
Yeah, I agree. And this is something that, as a technical director at CIBSE, I'm very keen. It's one of my kind of focus, to bring industry together, to work on projects that we could work together. Because that means that then when we sit around the table with the clients, then we say the same thing, we have the same goals, the same targets, the same objectives. And I think that's very, very powerful, that we all kind of speak the same language.
Yeah, absolutely. And it kind of like, it's almost like the metaphor of a building at the end of the day, because only if all the different parts actually work together properly, the building stays up and function as it should.
Correct,
If all the individual parts, they just do their own thing, then things will just crumble and we don't go anywhere. So fascinating. Is there anything else that, or let's say if you need, like, looking at the future.
Need to be more specific.
I know. Sorry, as I started, when I thought the question, I said, "Yeah, that's way too big of a thing." No, but in terms of like thinking again, the building industry, what we discussed so far. Let's say one big takeaway that people should really keep in the back of their mind when they think of new buildings, new products that can go inside buildings. Like, what should be one of the main focus area to make sure that we can reach, for example, those very important objective of 2050? I know there's a lot that can be changed, but something that stands up to you based on maybe the weather file that you've been working on, or some of the research that was done in the past.
I mean, ultimately for me, it's the curiosity, right? To ask the right questions. And if you ask the right questions, as engineers, we kind of can find the solutions.
Yeah.
Anything that has to do, and I would say that because that's kind of my focus for many years, anything that makes sure that our kind of environment and our way of life and they survive basically in the future. I would say that should be our priority. Making sure we don't make things worse, and we are focusing on making things actually better for the future.
Hello, curiosity was absolutely great. Yeah. Great headlines.
This is our superpower, right? As engineers, that we need to be curious. We need to ask questions about everything.
Yeah, you're right. Only if you ask the right question, you can set changes in motion. If you don't ask, nothing will ever change.
Exactly.
Wonderful. Well, thank you so much for joining us today.
Thank you for inviting me.
It was absolute pleasure. We'll put all the links to all the resources and the elements that we discussed in the description. Get subscribed. The audio version is on all the major platforms: Spotify, Apple Podcasts. Video is on YouTube. And I'll see you in the next episode. Thank you.